So, when it comes to the revenue vehicles, the vehicles that passengers ride on every day, whether it would be a bus or train, it is really important that we maintain them properly. Many transit agencies are working hard to maintain revenue vehicles in a state of good repair. What does it mean that passengers can ride on public revenue vehicles and can go to work on time? They can go to school, they can take their family to the store, even though the people who may drive a car, they can actually get to the places they need to go through public transportation. Hi, my name is Dilip Mistry. I am a data scientist at North Dakota State University and I work for the Small Urban and Rural Center on Mobility, in short, SARCOM, which is the program of the Upper Great Plains Transportation Institute at North Dakota State University. The objective of this research is to build a machine learning predictive model that will predict the projected retirement years of all transit vehicles in a small urban and rural transit system. Another objective is to calculate backlog and yearly replacement costs to achieve and maintain the state of good repair for the small urban and rural transit systems. This research was funded by the United States Department of Transportation through the Small Urban, Rural, and Tribal Center on Mobility, in short, CERTCOM, a partnership between the Western Transportation Institute at Montana State University and the Upper Great Plains Transportation Institute at North Dakota State University. Public transportation in a small urban and rural transit system play a vital role in providing mobility and accessibility while providing transportation alternatives and enhancing the quality of life. A lot of people rely on public transportation to get to work, store, school, and shopping center. So, when it comes to the revenue vehicles passengers ride on every day, whether it would be a bus or train, it is really important that transit agencies maintain them properly. They need to make sure that transit revenue vehicles remain in a state of good repair condition. Therefore, they need to replace their revenue vehicles on time. However, there is a concern that a significant portion of the small urban and rural public transportation revenue vehicles are past their useful life and need replacement to maintain them in a state of good repair conditions. The useful life policy by the Federal Transit Administration obtained is the primary benchmark guiding the timing of replacing revenue vehicles. However, some research published by the FTA showed that the actual ages at which agencies were retiring revenue vehicles from service exceeded the minimum service life assigned by the FTA. Another analysis of the average retirement age of transit vehicles on the National Transit Database data showed that the average retirement age actually was longer than the minimum required age in practice. Therefore, finding the actual service life of individual revenue vehicles and maintaining them in a state of good repair has become a strategic goal for transit agencies in a small urban and rural transit system. There are more than 1,600 small urban and rural transit agencies that provide services to tens of millions of Americans every day. However, most of the transit agencies do not have good asset management systems or tools. They are not sure when to retire their revenue vehicles. Therefore, operating costs are getting higher maintaining their revenue vehicles. The reliability of service decreases as transit vehicles break down during service. Public safety declines as transit vehicles fail to perform properly. As a result, transit vehicles are becoming less attractive and unreliable for potential riders. Therefore, achieving and maintaining a transit state of good repair is very crucial for small urban and rural transit agencies in order to provide reliable and safe services to passengers. In this research project, I built a predictive model using a machine learning algorithm that predicts the projected retirement years of all transit vehicles in small urban and rural transit systems. Since the machine learning predictive model learns from data, it gives accurate and realistic information regarding the predicted service life of revenue vehicles. This research also involves developing another financial analytical tool to calculate backlog and yearly replacement cost for revenue vehicles to achieve and maintain the state of good repair for small urban and rural transit systems. Since many transit agencies do not have a good analytical tool for predicting the service life of revenue vehicles, this predictive model as well as analytical tool would be a valuable resource for transit agencies to measure their state of good repair needs for a long range plans and would be helpful to measure their state of good repair backlog. This research will also guide decision makers on prioritizing capital investment on rehabilitation and replacement needs. For more information about this research, you can visit our website or contact me. At SARCOM, we provide research, education, and training opportunities for improving mobility in rural and small urban communities. Visit our website for this research and research projects, as well as an education program and other training opportunities. Thank you.